In this video, we're going to look at chamfer milling. When it comes to chamfer milling, there's two possible scenarios. One is we're going to be milling a chamfer on a part that's already been modeled in SolidWorks, and the other is we're precision deburring an edge that's currently a sharp edge on your model. Throughout the course of the video, we're going to discuss both scenarios. If you plan on following along, open and save Part 7.9. When we create a chamfer milling operation, we're actually just going to be creating a two-dimensional contour. So let's select 2D milling and 2D contour. From the library, we can select our chamfer mill and press select, and then move on to the geometry tab. The first chamfer we're going to look at is the one that we already modeled in SolidWorks. In this situation, we want to select the bottom edge. We need to make sure the tool is on the outside of the contour. I'm going to verify that my arrow is on the outside of the contour, so we're running around the outside of the part. And now we can skip over to the Passes tab. On the Passes tab, when we're using a tool that's defined as a chamfer mill, we have the option to create a chamfering operation. And this option will be activated by default when the chamfering tool has been selected. The top parameter will be used when we're chamfering a sharp edge, but the bottom parameter should be used in every situation. When we adjust the tip offset, the tool will lower and move away from the edge to maintain the same size chamfer, but machine it higher up on the tool. We're going to use an offset of 20,000ths of an inch. With our offset set, select OK. Now, let's quickly run through the process of applying the chamfer that might be better noted as a precision deburring operation to the edge of our bore. Again, we're going to select 2D milling, 2D contour. We're still using the same chamfering tool, and from the geometry tab, we're going to select that bore. Remember to double check and make sure your machining operation is machining on the inside of that contour, and we can move on to the Passes tab. Again, we want a tip offset of 20,000ths of an inch, but in this case, we also need to define the size of the chamfer. When you're using the chamfering operation to do precision deburring, my suggestion is to set the size to 5,000ths of an inch. Now, it's also very important to note, anytime you're using a chamfering tool for precision deburring, you should take a test cut, because it's very difficult to properly pick up your chamfering tool on the machine. And the variance of just 2 or 3,000ths of an inch is going to have a visible impact on your precision deburring operation. Now, with that said, let's select OK, and our toolpath is generated. Let's conclude this example by running a stock simulation. Remember, when we're doing simulation, we need to select the job folder to ensure that the simulation runs on the entire job. So, with my job selected, I'm going to select Stock Simulation and run the entire part. Here we can see the large chamfer that's been applied to the top of the part and the small precision deburring operation applied to the inside bore. I hope that inspires you to do more precision deburring on your parts and minimize the amount of handwork that has to be done after the parts come out of the machine.